Hey, good morning. And what I want to start talking about now is we're moving into circles. So we're going to begin by talking about the introduction to the circle, which is going to be very reminiscent of the time that you spent doing geometry in middle school, because this is just learning some basic terminology and its basic application to the circle itself. And in doing so, let's start with the radius. The radius of a circle. A radius is a segment that extends from the center of the circle to any point on the circle. So, a radius is a segment that extends from the center of the circle. So here we have the center of the circle, and this would be called, we could refer to this as circle K, no pun intended. And the center is K, and then the radius would extend from the center to any point on the circle, and N is on the circle. So that is one radius. And another radius might be that one that extends here from K to L, which is also on the circle. Now, the circle is the set of all points in a plane that are equidistant from a given point called the center. So that's why the circle is equidistant. So any point that goes from the center of the circle to the edge of the circle is the same distance. So that's why we will find that our radius are all the same length. And we also know that congruent circles will have congruent radius, because congruent circles just mean that they have the same radius. And then here we say that if circle K is congruent to another circle, then the radii of both the circles are congruent. But we do know mathematically, or here if we want to do it in, make sure that we know how to write it, that I do have, in this case, I have segment KL is going to be congruent to segment KN, because those two radiuses, the radii are congruent. Now, talking about chords, a chord is a segment with both endpoints on the circle. So a segment with both endpoints on a circle. So that chord is, we start here from H and F is on, both H and F are on the circle. And we also have here E and G. That is also a chord. And then we have a blank is a chord that passes through the blank of a circle. Could that be a diameter? All right, look at this. We have E passes through. And so, let's see here, not E per se, but EG passes through the center of a circle, which we've learned in the past that is going to be a diameter. So it's a chord that passes through the center of the circle. And some examples here for chords. One chord is that we have HF. We also have EG. For diameters, we have EG. And then for radii, or radius, we have DE. And we also have DG. So let's see here. We know that that is congruent to that. So those are just labeling some of the parts of the circle. Moving on to tangents and secants. A tangent of a circle is a line segment array that intersects the circle at exactly one point called the point of tangency and contains no points inside the circle. So a tangent of a circle is a line or line segment or array that intersects a circle at exactly one point called the point of tangency. So here is my line or segment, ray, whatever it is. I have ray PR, or I have segment PQ, and that intersects circle S at one point R. So R is my point of tangency, because that's the point where it intersects the circle. And then we learn that a secant is a line array that intersects the circle at exactly 2 points. So here we can see that the secant passes through the circle at 2 points. A tangent to a circle intersects the circle at exactly 1 point and contains no points inside the circle. Sorry, forgot to fill that one in. But a secant passes through the circle, so you do have secants passing into the circle, not just onto the edge. So that is the difference between a secant and a tangent. Then we talk about central angles and arcs of a circle. A central angle is an angle whose vertex is at the at the center of the circle and whose sides are radii of the circle. So we have, let's see here, we have angle EFG is a central angle. So EFG is a central angle. The vertex is at the center. And then FG would be a radii, FE would be a radii. And let's see here, what else do we have? They have the arc. The arc of a circle is part of the circle between two given points. So in this case, blank is an arc of circle F. There's probably several here. So it says is part of the circle between 2 points. Okay, so the part of a circle would be my circumference of a circle. And I could say that we have arc EG, right? I got arc EG, or EG is an arc of circle F. I could say that ED is a arc, because that is also part. Heck, we could say that DH is also an arc. So there are several arcs that we can identify, and they're overlapping, so you just never know which one they may be talking about, but it's part of that circle. And then the degree measure of an arc is equal to the degree measure of the central angle that intercepts it. So what are they saying here? They're saying that the degree of this arc of a central angle is going to be the degree of the angle. So since this angle EFG is 96 degrees, then I know that this arc is also going to be 96 degrees. And that's what that is telling us there. The degree is for a central angle, the arc is going to be equal to the degree. For semicircles, now a semicircle is an arc whose central angle has sides that intercept the circle at opposite endpoints of the diameter. And then you use 3 points to name this semicircle. So here we have AOC, no pun intended. That is our diameter, and then you can see that it passes through the center, and it is on opposite sides. So in order to name this, we would want to name it, let's see here, arc. And since it said 3, we could call it ABC, because that would be this arc right here. Boom, right there. Now, what else can we say? The blank is a central angle whose sides intersect the circle at opposite endpoints of a diameter. So in this case, we have angle AOC is a central angle, points on the circle passing through the center. And let's see here, blank and blank are semicircles of this. So we have one semicircle, which we have already identified, ABC. And then if we look and we went the other direction, we could have another circle, which would be ADC. Arc ADC, sorry, arc of that circle. And then the arc measure of any semicircle, well, the measure of a straight line or diameter is going to be 180 degrees. So then the semicircle would also be 180 degrees. And the measure of any circle all the way around that circle is 360 degrees. So these are values that will be important to us later. Minor arcs and major arcs. As we look at minor arcs, a minor arc is an arc whose measure is less than 180. And then that may surprise you to know that a major arc is an arc whose measurement is greater than 180. So in this case, we can say that arc AB is 110 degrees, and arc ACB, so let's see here, arc ACB is going to be equal to 360 minus that 110 degrees, which is going to tell us that that is equal to 250 degrees. So we have arc ACB is 250 degrees, where arc AB is going to be equal to 110 degrees. The arc addition postulate, just like when we had the line segment addition postulate, the angle addition postulate, what they're telling us is that if we have two arcs that are next to each other that share radii, then guess what? They're adjacent, they're next to each other. Then we can add them together, and I can say that arc CE plus arc ED is going to be equal to arc CED. And I did name it with 3 letters because it does appear to be greater than halfway. So anything in major arcs are identified with 3 letters. So there you go. So putting that to practice here in example number 1, we have, let's see here, AE and CD are diameters of circle B. Okay, so this is a diameter of and this is a diameter. And it says find the measurements of DE, so we need to find this one. Find the measurements of CE, so we need to find this one. And then find the measures of FAE, so it's going to be something like that. So we have a lot to look at. It's going to be overlapping, but what we do know is, first and foremost, let's do some labeling. I know that this is 50 degrees because these are vertical angles. If ADE right here is a diameter, then I know that this angle plus this angle is going to be equal to 180. So that makes this angle 130 degrees. I know that this is 90 degrees, and then by doing the math, this should be 40 degrees. So now I've got all my possible angles labeled. Now I just need to do the additions to it. So let's see here. DE, arc DE, we can see is going to be 50 degrees. Then we have arc CE. That is going to be 40 degrees, right? 40 degrees plus 90 degrees. 40 degrees plus 90 degrees. So added together, this arc right there is going to be 130 degrees. And let's see, what's the last one they wanted us to look at? They wanted us to look at FAE. So that is going to be from here, going through A, and stopping on E, which I could add all of those up individually, or I know that this is 90 degrees and it was not used, so that is going to be 360 degrees minus 90, which is going to be 270 degrees. So those are the measurements of those given arcs based on their central angles. Number 2 here, we're trying to recognize some stuff going on in our image, and let's see some easy things to identify, and there may be more, but there's only going to be one center though by Joe. the center is going to be point K. A radius, there's 3 possible radii. We have KJ, we also have KI, and last but not least, we have KL. So here, these 3 radii. Chords, now we know that chords go from one point on the circle to another point on the circle. So I see 3 possible chords. I see JL, I see JKI, and I also see HI. Those are my possible chords. So starting off with HI, then we have JKI, and we also have JL. Diameter, JKL is not only a chord, but it is also a diameter, and it is the only one that I see. So here's my diameter. A secant, remember a secant has one point on the circle and the other point passes through. So an example here would be I is on the circle and it passes through H and it goes on to J. So my secant here would have been segment GI is a secant. A tangent, gosh, a tangent was a point that rested just on one spot on the circle. It did not enter the circle. So a good example here might be this point J. We don't know that it goes anywhere inside the circle, so it goes from the outside, and I'm assuming it just touches at that one point. So that would be point J. Or should I say not the tangent? The tangent is actually GJ, right? Segment GJ. The point of tangency is going to be point J. Let's see, what else do we have? Inscribed angles. Gosh, we haven't covered those yet. Let's go ahead and cross those out. Minor arc. Minor arc is going to be an arc less than 180 degrees. Several to look at. I have, one easy one might be arc HI, because clearly it is less than 180. I also have JL, which is less than 180. I have IL, which is less than 180, and then I also have HJ, which is less than 180. So I have 4 possibles to choose from. HJ, not segment, but arc. JL, and then IL. Those are possible minor arcs. Major arcs, let's see, we do have arc JHI, because that would be this semicircle right here. We also have JLI, another semicircle right here. So I might as well go ahead and label those semicircles. JHI, JLI. And what else? Major arcs. Well, if I were to look right here, if I were to draw a diameter extending out this way, right, it looks like arc HIL is technically greater than 180 degrees. Arc JIH is over 180 degrees. So there's multiple ones that we can come up with there. But just understand, we didn't finish all of them, but you can have varying answers and still be correct. So, and then finally, this last example, we're going to throw a little bit of algebra into our geometry, and it says find the value of x. So we want to find the value of x. We want to find the value of angle EID. So EID, which is going to be this angle right here, and then what is the arc length of EID? So with that, let's see, I'm looking at vertical angles. So I have this diameter and this diameter, and they form two vertical angles right here. So I know that angle FIG is congruent to angle EIH. So I know that FIG is 103 degrees, and I know that I have to add two angles together here. I have this angle plus this angle, and I will end up having then 15 degrees plus 18x minus 2 degrees. So let's see here, start doing some inverse operations. And let's see here, I end up with 18x minus 2. And then 103 minus 15 is going to be, what is that, 88. Let's see here, continuing to combine like terms. I have 18x is equal to 90. Divide both sides by 18. And I believe x is going to be equal to 5. So I found x is 5. And then in order to find out what is the measure of EID, or DIE, we would go ahead and substitute in here because that is my angle measurement. So I have 18 times 5 is minus 2 is going to be 90 minus 2, which is 88. So this degree is going to be 88. And because my central angle and my arc length are the same degree, then I know this arc length is also going to be 88 degrees. So there you have it. We have angle EID is 88 degrees, and angle EID, arc EID is 88 degrees. So there you go. We are sitting on a bunch of introduction to circles material, and now we can continue on with our assignment.